it's Ray here. Welcome back to part 2 of the many ways you can factor. In the first video, I showed you how to factor out the greatest common factor. That's the simplest factoring you'll ever use. In this video, we'll be going how to factor trinomials, with a leading coefficient, factoring by grouping, and difference of squares. I wanted to start off first by factoring trinomials. So this right here is a simple trinomial. And trinomials are called trinomials because they have 3 terms. Each of these 3 terms has its own name. So this first term is called A, this second term is B, and this third term is C. So to factor this trinomial, we need to find a number that adds to give us B, but that multiplies to give us C. So in terms of this problem, we're going to be finding a number that adds to give us 7, but then multiplies to give us 10. The way I like to do it is I like to look at the factors of, the number that's being multiplied first. 10 is 1 times 10, 5 times 2. Okay, we have 2 factors here. I know that it cannot be 1 times 10 because 10 plus 1 is 11, it's not 7. But 5 times 2 is 10, but also 7 because 5 plus 2 is 7. So we know that the 2 numbers that will add to give us 7 will also be 5 and 2. So perfect. We found the very first step to this factoring problem. We found our 2 factors. Great. Now, what are we going to do with this x squared right here? Well, we need to split it up. And if you remember the first video, the way to split it up is just x squared is the same as x times x. So we need to split those 2 x's into 2 different groups. And by groups, I mean into 2 different parentheses. So one x will go here, and the other x will go here. And then what about the 2 factors that we found, the 5 and the 2? Well, it's simple. One 5 will go in here, and the other will go here. The 2 will go here. So it's going to be 5, or it doesn't matter where you put them, but 5, 2. And then notice that these symbols right here are positive, so these in here will also be positive. There will be instances when your numbers will be negative and positive, and the order will matter then, because if you put a negative where it does not belong, then your problem will be incorrect. Your factorization will be wrong. So make sure that you always look at the sign that you are using. That is an important part of factorization. So that is how you factor a simple trinomial. I'm going to show you this example and give you a few minutes to do it on your own. You can pause the video. All right, let's solve it now. Again, always write it down until you learn it. This is A, this is B, this is C. I need a number that's going to add to get me to B, but that will multiply to get me to C. B is -1. We need something that adds. And C is -12. Okay, again, let's look at the factors of 12 first. So 12 is 1 times, -12, -1 times 12, -2 times 6, 2 times -6, -3 times 4, 3 times -4. You see, it's the same numbers. The only thing that changes is the sign on them. And you need to have both options there so that you can visualize it. Okay, -12 plus 1 will give us -11. So this is not going to work if we want it to equal to -1. 12 minus 1 is 11. Again, it's not going to work. 6 minus 2, that's 4. Not working with me. -6 plus 2, that's -4. Again, it's not -1. 4 minus 3 is 1. Nope, we want -1. 3 minus 4 is -1, so we will be using this one. And we therefore know that the 2 numbers that add to -1 are 3 minus 4. Perfect. We just found the 2 factors, the 2 numbers. Great. Now, what about the x squared? As I showed you on top, that's x times x, and we need to split them into 2 parentheses. So parentheses, parentheses, x on one, x on the other, and then you take your 3 and put it here, and you take your -4 and put it here. So plus 3 minus 4, and that's it. All right, so now we're going to be factoring trinomials with a leading coefficient. In the last example where we just factored a simple trinomial, the leading coefficient was 1, so we were able to split up our x squared into x times x. But whenever our leading coefficient is not 1, or is 2 in this example, we cannot do that same maneuver. We have to do something else. And again, this all goes back to how we arrange our trinomial. So we have to remember, this is A, this is B, this is C. In order to factor the trinomial with a leading coefficient, we need to multiply A times C, and we need to therefore find a number that multiplies to give us A times C, but that adds to give us B. So it's the same thing that we did before with a new step, the multiplication of A and C. Perfect. So A here is 2, C is 3, 2 times 3 is equal to 6. We need to find a number that multiplies to give us 6, but that adds to give us B, which is 7. Perfect. Again, I like to start with the factors of 6. It's 2 times 3, 1 times 6. 2 and 3 is 5, that's not 7, but 1 plus 6 is 7, and 1 times 6 is 6, so 1 plus 6 is gonna work for me. So now we did the first step. We found our two factors. The second step is to rewrite our trinomial. We're going to conserve or keep the 2x squared plus 3. We're also going to keep the 3. The difference now is that we're going to take our 7x and split it up into 1 and 6. So it's going to be 6x plus 1x. Great. The other new step is that we're going to be grouping. Grouping is just what it sounds like. We're going to take the first two terms and group them together, and the last two terms and group them together, so that this becomes 2x squared plus 6x times 1x plus 3. Now we're going to go ahead and simplify what we have right here. So what is the greatest common factor of 2x squared plus 6x? The greatest common factor is going to be 2x because they both share a 2 and they both share an x. Inside the parentheses, we're going to be left over with x plus 3. What about here? 1x plus 3. What is the greatest common factor? The greatest common factor that these two share is just 1. And inside the parentheses, we're also going to be left with x plus 3. We have 2x plus 3's. You can just reduce that to 1x plus 3. And then you form your other parentheses by taking these two terms that you factored out. So your new parentheses is going to be 2x plus 1. And that's how you factor your trinomial when there's a leading coefficient. Notice that in the other example, it was typically x plus a number times x plus a number, but because we have 2, it's going to change a little bit. Instead of being x, it's now going to have a 2x in front. All right, so the next factorization method is to factor by grouping. Factor by grouping is very simple because it's just what it sounds like. You're going to take your first two terms, x cubed and 5x squared, and you're going to group them, and you're going to take your second two terms, 2x plus 10, and you're going to group them into one parentheses. So let's start by doing that. X cubed plus 5x squared, close parentheses, open parentheses, 2x plus 10, and then close your parentheses. Great, you've grouped them. What now? Now we have to apply the GCF, which is something that we learned in the first video of this series. We need to find the greatest common factor. So what is the greatest common factor in this first parentheses? Well, we know that they both have 1, and they also both have x squared. So what we can do here is we can take x squared out of that parentheses, and then inside we're going to be left with x plus 5. What about this here? What is the greatest common factor? Well, I know that both of them have 2 because 1 times 2 is 2 and then 2 times 5 is 10. They don't both have x, so x is going to stay here. I'm going to take the 2 out, I'm going to factor it out, and inside the parentheses I'm going to be left with x plus 5. Great. Now I'm going to go ahead and combine these two into one parentheses, x squared plus 2, and only take one of these. because it's the same. X plus 5, we're just going to bring one of them down. So it's going to be x plus 5. All right, so factoring by grouping is just this. You first start by grouping your first two terms, grouping your second two terms, factoring out the greatest common factor, and then just putting these two together and bringing one of these x plus 5s down. If you did not understand how I did the GCF, you can go to part 1 of this factoring series where I show you how to factor out using the greatest common factor. It's important that you understand how the greatest common factor works because you're going to need it for every other factorization method. Lastly, we're going to take a look at difference of squares. Difference of squares is also very simple to understand because all you need to know is the difference of squares identity, which is as such. A squared minus b squared is equal to a plus b times a minus b. All right, so what do we do with this now? All we have to do is we need to first find a and then find b. So a is x because x is what's being squared. B, however, is a number that you square to get 25. So the best way to figure this out is to take the square root of 25 to get plus minus 5. So we know that A is going to equal x and B is going to equal 5. Great. Now that we have that, all we have to do is substitute A and B into this part of the identity. So it's going to be parentheses x plus 5, or A plus B, times x minus 5, or A minus B. It's important that you always have a plus on one parentheses and a minus in the other. And that's how you factor x squared minus 25. Now you can go ahead and try this example. You can pause the video, but I'm going to go ahead and solve it immediately. Again, remember the identity. A squared minus b squared is equal to a plus b times a minus b. We know that a is going to be x, and that b is going to be the square root of 9, which is plus minus 3. So now we know that this is a, and we know that this right here is b. So all we have to do is substitute x plus 3 times x minus 3. And that's essentially how factoring difference of squares works. This will work for any square such as 4, 16, 25, and 9 like we did in this example. And it's pretty simple because all you have to remember is this right here.